Welcome to Calbeckistan, the place where anybody can learn math. I'm Mr. Calbeck, and this is episode 3 in our Inequalities crash course. We're going to take a look at some more complicated problems relating with inequalities. Let's get started. As a quick refresher before we get started, remember that you can treat inequalities almost exactly like an equal sign, with the one exception if you multiply or divide by a negative. If you haven't watched that episode yet, there's a link in the description. Since this is exactly the same except for that one rule, we can solve this the same way that we did in our entire crash course series, and all those principles still apply. So, wow, that's loud. Since we know that it's essentially an equal sign, all of those same rules apply. So let's see if we can solve this. Again, I want to get all of my x's on one side. But remember, when I multiply or divide by a negative, I have to remember to flip my inequality. So as often as possible, I want to try to keep my x positive. So I could choose a couple of things here. I could add the 3x to both sides. But what would happen? Negative 4 plus 3 is still a negative number. So instead, I'm going to take that extra minute to think about which one makes sense to add, and I'm not going to add the 3x, I'm actually going to add the 4x to both sides. Because what that does is it keeps my x positive, and it keeps me from having to switch anything around. So that leaves me with a 1x, and I don't need to write the 1. So I have x plus 4 is less than or equal to 9. I'm going to go ahead and subtract 4 from both sides. And you end up with x is less than or equal to 5. Now all we need to do is graph this. Remember, when we're going to start here, we're going to find 5 on the number line, and if you're just drawing it, generally I put 0 and 5 so that I can keep track. And again, this is not an arrow, this is an alligator. It's eating the 5, which means x has to be smaller. It's all the numbers less than 5. So I'm going to put my dot here, and because this takes more ink, I'm going to fill it in, because this needs to match. And I want to find all the numbers that x could be that are less than 5. And if you ever get tripped up on this, just pick a number. Let's pick 4, for example, and see if this is true. Is 4 less than 5? Yeah, that's true. So my arrow should go towards the things that are true. Not too bad, right? It can get more complicated, so stay tuned. All right, so for this one, we want to solve it just the same. The only difference between this one and the last one so far is that I don't have an equal sign there. So you should, when you're graphing it, be thinking at the beginning, this is an open dot. It takes less ink. All right, so the first thing I want to do, just like in a normal solving problem, if you have a number out here, you probably want to distribute it in. So I'm going to rewrite this as negative 10x, because it's being multiplied. Negative 2 and 11 is negative 22, and that's all less than 8, or all greater than 8, rather. Okay? Quick note, even though I distributed a negative 2, since I did not do it to both sides, I do not have to remember to switch the inequality there. All right, let's keep going. I'm going to add 22 to both sides. Just like we would in normal algebra. Again, nothing is really very different here until you get to this step. Now I have a negative 10x is greater than 30. I need to divide by negative 10. Remember, that's that one rule you have to remember. I just divided by negative 10 on both sides, so I should have some alarms going off in my head. Wow, that was loud. And the alarms are going off because I divided both sides by negative 10. So that's going to cancel out again to a big 1, because anything divided by itself is 1. That leaves you with x. This inequality gets reversed because I divided by a negative, and I end up with negative 3. Really important that you remember that rule. This is going to be the one thing that trips you up in this chapter. If you can do all of the algebra, this is the one new thing that you have to remember. Then when I graph this, it should be pretty straightforward now because my inequalities go in the correct direction. I want an x that's bigger than -3. So again, in my number line, I'll put a 0 and then -3. My x is smaller than -3 because again, the alligator is eating the -3. That's the pretty dope alligator right there. So I'm going to go ahead and put my open dot right here because it's less ink, it matches the less ink of my inequality, and I want numbers that are smaller than -3 because x is smaller than -3. Those are numbers this direction. Now again, you can pick a number just to make sure. Maybe I'll pick a number way out here. 10, for example. I want to make sure my arrow is going the correct direction. So that means I'm going to check to see if x could be 10, and this is still true. Would the alligator eat the -3 if x is 10? No, the alligator wouldn't. The alligator would be eating the 10, which means this is completely wrong. This is false. I'm going to put an x there, and that means my arrows go in the right direction because this is a false statement. I want something that's true, so my x has to be numbers on this side of the -3. And if you can do those steps, you're going to be in great shape. All right, one more example here. Again, we've got an inequality with an equal sign underneath it, so I'm going to have a dot because it needs to include the point. It needs to be filled in, dot there. And we're going to go ahead and solve this. Remember, all the same rules apply. Subtraction, I'm going to add, which leaves me with a -x over 4 less than or equal to 10. And this is being divided here by 4. Now, most textbooks will have a negative out in front, but you can also, anytime you see a negative in the front, you can think about it as actually going with the denominator. That's fine. It can also go with the numerator. It just has to have 1 though. So what I really want to do here, if I want to get x by itself, is I need to multiply by a negative number. Okay, so I'm going to multiply both sides by -4. And that's going to cancel out that -4 there. But I just multiplied both sides by a negative. So my alarm's going off in my head. Gosh, that is loud. And I've got x. Because my alarm went off, I need to reverse the direction of my inequality. And x is now greater than or equal to -40. Let's go ahead and do my number line. Again, I'm going to put 0 in the number here, just so it's important that you know which side of the 0 that your number is on. I'm going to put the dot over the 0. And I want to know all the numbers for x that are bigger, because remember, my alligator is eating the x, which has got to be larger than this. All the numbers that are bigger than -40 are to the right. And that's about it. Inequalities are really the same as equations, with the one exception of multiplying or dividing by a negative. So just be really careful with that. But if you have watched through the solving crash course, you can solve any kind of inequality that I could throw at you if you remember that one additional rule. So again, that link is in the description. If solving is still challenging for you, you should start there. But I think you guys are going to do great. Stay tuned next time when we start talking about compound inequalities. Yeah, it's not as scary as it sounds.